Hello children, continuation of gravitation, that gravity. See, we have learnt about gravitation, a previous video, as the phenomenon of attraction between any two objects or any two bodies in the universe. So gravity is one particular case of gravitation when one of the two attracting bodies is Earth. Hence, the gravity is the phenomenon of attraction between Earth and any other body. Got it? The force of attraction exerted by Earth on the body, which is called force of gravity. Right? So, the gravitation, which is nothing but the attraction between any two objects. The gravity, which is the phenomenon of attraction between Earth and the center of the body. You must know to differentiate both. And the force of gravity is calculated using universal law of gravitation, that is governed by Newton. M1, which is equal to, we can take M, which is equal to mass of the body, and capital M, we have taken mass of the earth. R is the radius of the body. From the center of the earth we have to take it always. So capital F is the force of gravity exerted by earth on the body. Then from Newton's law of gravitation, capital F, that is F force, which is directly proportional to M1 M2 by R squared, we have studied, right? So F, which is equal to G M1 M2 by R squared. We have taken small m as mass of the body and capital M as mass of the earth. We are substituting that value here. So F, which is equal to G mm by R square. So as mass of the earth M is large, the force of gravity acting on the bodies is quite large as compared to the gravitational force of attraction between any two bodies of small masses, right? Now, we'll see free fall. See, the free fall is the concept of acceleration due to gravity. We can say that every body on earth is attracted by earth towards its center. Clear? So, therefore only we are saying that every object when free falls towards the earth due to the gravitational force of earth. So how can we say free fall? Free fall, which is nothing but what? All objects falling towards earth under the action of gravitational force of earth alone, we can say free fall, right? So the earth, what it is doing, that attracts objects towards because of the gravitational force. So when it is free fall towards the earth due to the earth's gravitational force, so that is free fall. Got it? The acceleration due to gravity is denoted by small g, as we said. We know that for that unit of acceleration is meter per second square. From the second law of motion, we can say force is the product of mass and the acceleration. So F, which is equal to ma, we know that. For free fall, force is the product of mass and acceleration due to gravity. So F, which is equal to mg, or we can say mg, which is equal to g mm by r square, or here d square, the distance between them, or g, which is equal to g m by d square. So mass is, m is the mass of the, capital M is the mass of earth, and d, which is distance, we have taken here. So for objects near or on the surface of the earth, then d is equal to the radius of r. We will see one by one elaborately. See the relation between g and g. We know that the small g, which represents acceleration due to gravity, and capital G, which represents a universal gravitational constant. To establish the relation between G and G, we have taken, suppose Earth we have taken is a perfect sphere, but it is not through that much of perfect sphere of radius capital R and mass capital M, we have to consider a body of mass M is held at a distance of R from the center of the earth. We can calculate from according to Newton's law of gravitation. The force of attraction exerted by the earth on the body is what? We know that F, which is equal to Gmm by R square. See, we know that when the body is free, it falls towards the center of earth due to gravitational pull of earth. So the acceleration in free fall is acceleration due to gravity. That is only we have denoted by small g. See, according to Newton's second law of motion, the force is the product of mass and acceleration. Therefore, the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to gravity. So that only we can say F, which is equal to mg, and we can say that mg, that is equal to F we said, so that we can replace force F instead of mg. So mg, which is equal to Gmm by R square. So that only we said g, which is equal to capital G capital M by R squared in free fall. By the relation of g and g, you can get clearly about how it came, right? So this we can call it as the relation between the small g and capital G. And if the body is on or near the surface of the earth, we can say the distance r, which is equal to capital R, right? The radius of the earth. And for that only we can say for objects on or near the surface of the earth, the small g, which is equal to Gmm by, instead of the small r square, we can write capital R square. Okay. Now, we can see that the acceleration due to gravity does not depend upon the mass of the body. See, from the relation we can take g and g, that we know that small g, which is equal to Gm by R square, where g, which is equal to gravitational constant, the capital M, as we know, mass of the earth, and capital R is the radius of the earth. See, we observe from this relation that the value of small g depend on mass of earth, radius of earth. Is it right? See, mass of the body small m is nowhere involved here. So it means that the value of acceleration due to gravity, does not depend on the mass of the body. So that we can say all bodies when free will fall towards the center of the earth with same acceleration, whatever it may be the masses.